for today is about integrals yielding logarithmic functions.
So at the end of the lesson, you should be able to identify functions whose integrals result to natural logarithmic functions, illustrate solutions on problems yielding natural logarithmic functions. So recall that in Calculus 1, the differential of natural log of u equals du over u. And evaluating the integral of both sides of this equation gives us the integral of du over u, which is equal to the integral of the differential of the natural log of u, or the integral of du over u is the natural log of absolute value of u plus the constant c, provided that u is not equal to 0. So we put the absolute value sign for the argument of the natural log of u because the argument of the natural log of u must always be a positive number. So this formula says that the integral of any quotient whose numerator is the differential of the denominator is the natural logarithm of the denominator.
Okay, so let us now apply the integrals yielding logarithmic functions where the integral of du over u is the natural log of absolute value of u plus the constant c. So for this problem, we are asked to evaluate the integral of x plus 3 dx over x squared plus 6x minus 1. So using this formula, we let the denominator of the integrand as u. So we have u equals x squared plus 6x minus 1. And then taking the differentials of both sides, so du is 2x plus 6 times quantity dx. And because 2 is common, so we can factor this out. So you have 2 times quantity x plus 3 dx equals du. And if you observe, your du is similar to the numerator of the integrand. So there is only a missing constant of 2. So to make it equal, we have to remove 2 from this side. So you divide both sides by 2. So cancel this out. So therefore, 1/2 du is equal to x plus 3 dx. And now, because this is now similar to the numerator, we can now apply the substitution method. So you replace x plus 3 dx by 1/2 du over the denominator, u, which is x squared plus 6x minus 1. Then to integrate this, factor out the constant 1/2. So we have the integral of du over u. But recall from the formula that the integral of du over u is natural log. So this is 1/2 times the natural log of absolute value of u plus the constant c. But because u is defined in terms of x as x squared plus 6x minus 1, so we have to replace u by this expression. So this is the final answer. No, we have 1/2 natural log of x squared plus 6x minus 1 plus the constant c. But you can also rewrite this as the natural log of absolute value of x squared plus 6x minus 1 quantity raised to 1/2 plus the constant c. Or other may rewrite this as in radical form as the square root of x squared plus 6x minus 1 plus the constant c. So any of this can be used as your answer. Okay, so let's take another example. Suppose we are asked to evaluate the integral of x cubed plus 3 dx over x plus 1. Because this rational function is improper na because the degree of the numerator is greater than the degree of the denominator. So what you have to do is you need to divide the numerator, which is x cubed plus 3, by x plus 1. But because x squared is missing, so you leave a space for x squared, for x, And then for the constant, you have 3. So this is plus 3. Then divided by x plus 1. So to get the first term of the quotient, you divide the first term of the numerator by the first term of the denominator, which is x. So you have x cubed divided by x. We get x squared, and x squared times x is x cubed. Plus x squared times 1 is x squared. And then subtract. So you have x cubed minus x cubed. This is 0. Then 0 minus x squared is negative x squared. Okay, then plus 3. Then do the same. You divide the first term of the new dividend by the first term of the divisor. So negative x squared divided by x. So this should be negative x. Negative x times x is negative x squared. And negative x times 1 is negative x. And then subtract. So this is 0. And then this becomes 0 minus negative x is positive x plus 3. Then divide again. So x divided x is 1. So you have plus 1. Multiply. 1 times x is x. And 1 times 1 is positive 1. Then subtract. So this is 0. This is 3 minus 1 is 2. So this is the quotient. So therefore, the integral of x cubed plus 3 quantity times dx over x plus 1 can now be written as the integral of x squared minus x plus 1, which is our quotient, plus the remainder 2 over the denominator, which is x plus 1. And then we break this into 4 integrals. So you have the integral of x squared dx minus the integral of x dx plus the integral of dx. Plus, we factor out 2. So you have 2 times the integral of dx over x plus 1. But we call that x squared dx is of the form x to the n du. So we can apply power formula. So the integral of x squared dx is x cubed over 3 minus, same for the second term, this is of the form x to the n du. So the integral is x squared over 2. Plus the integral of dx using formula number 1. So we have x plus 2 times the integral of, in the last term, okay, we can rewrite this as by letting u as the denominator, which is x plus 1, and du as the differential, which is dx. So we can rewrite this as du, no? Because du is dx, so we can write this as du over the denominator x plus 1, which is u. So this is of the form du over u. Okay, so we have x cubed over 3 minus 1/2 x squared plus x plus 2 times, recall that the integral of du over u is natural log of absolute value of u plus the constancy. Or this can now be written as 1 over 3 x cubed minus 1/2 x squared plus x plus 2 times the natural log of u, where u is x plus 1 plus the constancy. So this is the final answer. So in summary, after learning how to evaluate integrals yielding logarithmic function, then we can say that whenever there is a rational integrand, it might be possible that it can be integrated using the integrals yielding logarithmic functions.